discrete random variable. Variable. In chapter 2, we had two types, variables. Who are the two types? Can you remember them? Two types. Okay, what? No. The dependent, independent was here. I mean, I'm asking you the two types of the variables in chapter 2. Categorical and numerical, yes. Qualitative, quantitative. Categorical or numerical. It's like as chapter 3. In chapter 3, we use only the numerical. Again, the random variable. The random variable is always the numerical. So we are going to use the numerical variable again in chapter 5. Just a second. In chapter 2 again, we had another two types for the numerical variable. Can you remember the map? You know, the top was the categorical variable and numerical variable. And numerical variable had another two types. Discrete and continuous. Thank you. See? Discrete. Random variable. Chapter 5. What do you expect? Chapter 6. Continuous random variable will be in chapter 6. As I told you, random variable, it is a numerical. So, first, we are going to discuss discrete random variable in chapter 5. What was a discrete? I told you discrete was countable. 1, 2, 3, 4, 5, and 6. So please look at this example. The x, x is a random variable. What? Denote the total number of heads. Number of heads. 0, no head. 1 head. 2, 3, 4, 5, 6, 7, countable. Discrete, numerical variable. Discrete, random variable. Just a second, what is a random then? How do you think? What is a random? It is the probability, by chance. So now I can say random variable is a numerical variable by chance with the probability. It is a random variable. So here's a definition. Here's a definition of the random variable. A random variable is quantitative numerical, whose value depends on a chance with a probability. Yes, that is. So please look at this example. That is the number of siblings, the brother and sisters. If you are the only son, then the number of siblings will be 0. If you have one brother or one sister, then it will be 1. Actually, I have 3 sisters. So my x, the number of siblings, number of something, discrete numerical, my x will be 3. And here is the probabilities. Yes, random variable. It is a numerical variable by chance with the probability. Just a second. In chapter 3, we made frequency table, histogram, dot plot, stem leaf. In chapter 4, we made a box plot with what? Numerical variable. Yeah, we made them. Again, because the random variable is a numerical. Why not? Let me make the histogram. No sibling, 20%. So I can put here as a probability on the vertical x. It's a 20%. 1.425. Just a second. Here's a 1, 2, 3, and 4. 0.425 is a little bit higher than as 0.4. And 2.275, 0.275, and 0.075 for 3 is less than 10%. 0.075 and 0.025. Yes. We can make the histogram to show shape of the distribution because the random variable is numerical with the probabilities. Who is the most? One sibling, one brother, or one sister. It is the most. What is the least? It's a 4. Yeah, we can see them. So it is the random variable. Discrete type, countable. So always it must be number of something. Okay, so look at the next one. In the next one, when we are toss a dime 3 times, toss a coin 3 times, the random variable x was the number of head. X equals 0. What does that mean? Every single time we got tail, tail, and tail. How about the x equals 1? 1 head, 2 tails. So, H, T, T, H, T, H, T, 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 H. Can you understand what does it mean? The first one, head, and then 2 tails. Tail, head, tail. Tail, tail, and the last one is a head. They are all x equals 1. What was the x? What was the random variable? The number of heads. How about x equals 2? How do you think? H, H, T, H, T, H, and T, H, H. It's good? How about the last one? X equals 3. 3 heads out of 3. H, H, and H. Let me collect them all to make the sample space. Do you remember the sample space? Big S. Now I can say it's a H, 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 T, H, T, H, H, T, T. And T, H, H, T, H, T, 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 H, T, T, T. How many possible outcomes in the sample space? 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes in the sample space. From what kind of experiment? Toss a dime 3 times. When we define a random variable x, which was the number of heads, it can be 0, 1, 2, 3. What is the x? It is a random variable. Then now we need the probability. How do you think? What is the probability for x equal 1? We had one outcome for the event, one head, no head. Out of, we need the probability now, out of, in the denominator, which was the number of possible outcomes in the sample space. How many possible outcomes in the sample space? 8. How about the second event? One head. Random variable x is equal to 1. How many outcomes? 3 out of 8. Yes?
I guess I'm confused how you got all the, like 3, HT, HT, and all of those in each out.
I mean, for these outcomes,
Yeah.
you know, you have to understand the step by step. What was the experiment? Toss a dime 3 times. So can you understand the sample space next? We can have 8 kinds of possible outcomes. So the sample space was a collection of all possible outcomes. H means when I'm tossing a dime 3 times, we will get head, head, head. This one, tail first, head second, and head. It's good, right? And now, in chapter 5, we have a new one, the random variable. It's kind of an event.
Okay.
The x equals 0, that means it's no head. What does it mean? No head out of 3. We got tail, 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 right? One head, just one head here, one head there, and one head there. 2 heads, 2 here, 2 here, there, here, right? But now we need a probability as well.
Okay, that makes sense. I'm sorry.
Exactly same idea. How many outcomes in the event? Up there, at the bottom, denominator, how many was in the sample space?
Okay.
So we just apply the probability again. We just apply the definitions in chapter 4 again, but additionally, we added random variable. So let me keep going. X equal 2. 2 has. It has 3 outcomes again. Another 3 outcomes out of 8. And the last one, only 1 out of 8. So can you take the probabilities from the defined random variable? Any question? Please.
I'm confused.
For what?
Oh, just kidding.
So you're counting 3 tosses for each, but for the TTT, there's only, I mean, that's the only option.
Yes.
I'm confused why it was 1 out of 8, because there's not even an 8.
Here is a 1 outcome out of 8. That is the way we got the probability before in chapter 4. You know, I understand. Yeah, this is the first time. Yeah, we are going to do again. It's more examples in chapter 5. Yes. So just to keep going. So even still you don't have any idea. Yeah, please ask me.
So on the 2,
X equal 2.
because there's 2 H's in each 3. Okay.
Yes. Then we had 3 outcomes out of 8 outcomes in the sample space. Because when we got the probabilities from the number of outcomes, how many outcomes in the event over how many was outcomes in the sample space. That was a definition of the probability in chapter 4. So we just add the new one, the random variable. But it's kind of an event. right? So for each event, for each value for x, random variable, we just count how many outcomes out of 8. How many outcomes out of 8. So now, can you add up? Can you add up all 4 probabilities? 1 over 8 plus 3 over 8 plus is another 3 over 8 plus and 1. 1, 3, 3, 1. 4 and 4. 4 and 4. 8 over 8. Always, when we define the random variable with all probabilities, then sum up all probabilities, always 1. Because, look at this. We just split. We just split the sample space. It's a case by case, event by event. Sum up, again, they will be the sample space. How much was the probability of the sample space? Which was 1. Do you remember that? Yes, it is.